Chemical Engineering Plant Economics. I am Dr. Samidha Banka from Department of Chemical Engineering, Sri KJ Polytechnic, Bharuch. Throughout this course, we will learn how chemical engineers convert an idea into successful industrial project by combining engineering principles with economic analysis. This subject is not limited to designing equipment. It also includes selecting suitable materials, preparing plant layouts, estimating project costs, evaluating profitability, and making investment decisions. In simple words, this course teaches us how to design a chemical plant that is technically sound, economically profitable, safe, and environmentally sustainable. By the end of this course, you will understand the complete journey of a chemical plant from concept to commercialization. Before learning about plant design, let us first go through the contents of this course. The entire lecture series is divided into five parts based on the five chapters or units described in GTU curriculum. The first one is Introduction to Chemical Engineering Plant Economics. The second one is Development of Project for Plant and Process Design. Third is Selection of Chemical Engineering Equipments. Next would be Plant Layout and Location. And finally, we will be learning about Economic Evaluation of the project. So let us start with chapter 1, Introduction. A chemical engineer applies the principle of chemistry, physics, mathematics, and engineering to convert raw materials into valuable products safely, economically, and sustainably. Now we need to understand that what are the various roles of a chemical engineer. A chemical engineers work in many different roles. As an operation engineer, it ensures smooth and efficient plant operations. As a maintenance engineer, it maintains equipment reliability and minimizes downtime. As a process control engineer, it monitors plant parameters using automation systems. As design engineer, it designs new processes, equipment, and plant layouts. As an HSE engineer, it ensures health, safety, and environmental compliances. As a planning engineer, it works on production planning, schedules, and resource utilization. As a reliability engineer, it works on improvement of equipment performance and plant availability. A plant manager is someone who manages overall plant operations and productivity. And finally, an R&D engineer that develops new and improved manufacturing processes. Thus, a chemical engineer plays an important role throughout the life cycle of every chemical plant. Now, can you identify which role is mainly responsible for designing a new chemical plant? Write down your answers in the comment section. Now that we know responsibilities of chemical engineer, let us understand what chemical engineering design actually means. Now, chemical engineering design is a process of transforming an industrial idea into practical and commercially viable manufacturing plant. Okay, it involves selecting of suitable processes, preparing material energy balances, design equipment, plant utilities, developing plant layout, selecting material of construction, and evaluating project. Okay, a successful chemical engineering design should follow all these objectives, that is safety, economy, efficiency, environmental protection, flexibility, and expandability. Okay, so what are the various components and steps of a chemical engineering design? So first one is process identification, wherein you identify the need and objective of process or chemical engineering design. Then you select the most feasible chemical process. Then you conduct the experiment in the on in lab, that we call as lab scale, okay, where you conduct experiments and then you obtain data on yield, conversion, byproducts, etc. Then you again perform certain set of experiments on bench scale or pilot plant. The pilot plant or bench scale is typically you use larger equipments, more quantity of chemicals, and they mimic or they are like replica of the commercial plants. So perform experiments in bench scale equipment and study process parameters and operating conditions. Here you even understand if there are safety concerns or various you can say critical points in your plants could be. Next one is preliminary economic evaluation. On the basis of your pilot studies, you will determine the you can say approximate cost of the plant, and on the basis of what else things you will be needing. Then process development, you try to optimize your plant in such a way, your pilot scale plant in such a way that you are getting maximum efficiency along with other parameters. Then you conduct mass and energy balance. Okay, and in this mass and energy balance you even try to scale up. Okay, then you have to go for the commercialization. So now you need a big place, so you go for site selection. Then you do a detailed economic evaluation. This includes um, fixed cost and capital cost of your plant, establishment, and as well as startup, along with other taxes and loans and everything. Those all things you detailed you do here. Then you draw your engineering diagrams. Okay, so engineering diagrams in terms of flow sheets, all kinds of flow sheets are being developed, because whatever you have done mathematically has to be put in terms of figures in the designs. Okay, so you have process flow diagram, block flow diagram, you have piping and instrumentation diagram, you have utility diagram, you have material and energy balances diagram. So all sort of designs are there. Then you have mechanical designs also that you have to present. Once these designs are ready, then you prepare a detailed process designing. Now here there is every tiny detail of the process that is going to happen in the plant. Okay, every tiny detail is there here. Next one is procurement and construction. Once everything is on the paper, everything is ready, then you start procuring. That is, you start collecting or buying your material, and you start construction. And once the construction is done, then comes the startup phase. That is where you commission the plant and start the operation and achieve the design objectives. Okay, so these are the various steps or components of the chemical engineering design. Moving on, we need to understand what are the outcomes. So a successful design should give us the following outcomes, that is reliable plant operation, optimum investment, quality products, customer satisfaction, and sustainable growth. Here's a small quote written in very tiny font. You can see, good design to ensure better performance, lower cost, and sustainable future. Okay. And then you can see that how we start, we innovate, we design, we build, we operate, and then we excel. This goes with all kinds of design activities. Moving on, next we need of plant design. So why do we need a plant design? Okay, let us find out. So plant design is required whenever a new manufacturing facility is established or an existing plant is modified or expanded. Industries redesign their plants for many reasons. They may want to introduce a new product, replace outdated technology, improve energy efficiency, reduce product cost, enhance safety, increase production capacity. Okay, or solve operational problems. Plant design also helps in optimizing material utilization, improve process control, comply with regular regulations. Okay, without proper planning and designing, industries may experience low productivity, high operating costs, safety hazard, and poor product quality. Therefore, careful plant design forms the foundation of every successful chemical industry. Now, plant design begins with process design. Let us understand this concept now. Process design is the first engineering stage of plant design. It defines how raw materials will be converted into finished products. We define process design uh, as a sequence of chemical and physical operations, operating conditions, major equipment, material of construction, line sizing, and instrumentation required to convert raw materials into valuable products safely and economically. So this is how we design. Now the steps of the process design remain similar to those of the chemical engineering design, because the entire chemical engineering design depends on the process design itself. So see, we know that the process is the heart of chemical engineering. Okay, whatever the reaction is taking place, we have to design the entire plant on the basis of that. So more or less all the steps remains the same, like process identification, then laboratory scale process research, then bench scale investigation, then preliminary economic evaluation, process development, mass and energy balance, site selection, detailed economic evaluation, engineering flow schemes, then you detail design your process, then procurement and construction, and finally the commission. I'm not going again into the details because the steps remain more or less the same. Now let us understand the principles of good process design. So safety first, economic operation, high efficiency, environmental protection, flexibility and expandability, reliability and ease of operation. So these are the principles of good process design. We use various tools and techniques like various kinds of process simulators, SPM plus, HISYS, ChemCAD, DWC, etc. Then we use material energy balance calculations. Then we conduct engineering calculations and design codes. We match them. And finally, we do the risk assessment, hazard studies, safety analysis, and so on and forth. So what will be the outcome? And a well-designed process ensures safe operation, optimum use of resources, high efficiency, product quality, environmental compliance, and economic viability of a chemical plant. Again, as mentioned, the steps goes like idea and concept, then detailed design, then plant realization, and finally the value creation. So this is how a process design works. Once the process has been finalized, then the next step would be selecting a suitable. So design and selection of chemical engineering equipment. Now every chemical plant contains numerous equipment such as reactors, pumps, heat exchangers, distillation columns, compressors, storage tank and piping system. Selecting the right equipment is essential because it directly influences plant efficiency, safety, product quality, and operating cost. So, the objective of design and selection is to design equipment that can perform the required function safely, efficiently, and economically throughout its operating life, and to select the most suitable commercially available equipment. Okay, so now there are two things over here. Okay, don't get confused. One is we are designing an equipment, and second one is we are selecting. So first, let us start with the design. So design process includes that first we need to define the service. That means we need to plan that what kind of operation or process we are going to do, what would be the operating conditions, what would be the process requirements, and so and forth. So we define our process or operation. Then we determine the design data. Okay, then basis on whatever equipment you need, we design that equipment. For designing that equipment, we do various calculations, size and dimension, thickness, heat mass transfer, process calculation, and everything. Once that is done, then we select the material of construction. What does material of construction should comply with? Okay, so it should be corrosion resistant, temperature suitability, mechanical strength, havability, and cost. Okay, so these are few things that we need to take into consideration. Then we go for a detailed design where drawing and specification, nozzle and fitting, supports, attachments, and the design is in order with the codes. It is complying all the codes needed, that has to be checked. Then we evaluate and optimize on the basis of safety, cost, reliability, efficiency, and then we finalize the design. Once the design is finalized, then we give the order to the commercial vendor or whoever is going to design or manufacture that equipment. So this is major design process steps. Okay. Now, moving on, if we want to select an equipment, okay, so what do we do? Again, we determine the process requirements or service. Okay, then we check for safety and reliability, material compatibility. Material compatibility is whatever chemicals you are going to use, the material of construction of that equipment should be compatible with that. Then cost, of course. Then we see manufacturing and availability. Okay, so if it is easily available or what. Okay, then maintenance, we also have to check that it is easy for maintenance, easy for operation, easy for installation, and all those things. Then we look for flexibility. If we are getting an equipment, we need to see that if we need to scale up, or if we need to revamp, or if we need to change something, that can be done or not. And finally, again, we need to check for the code and standard compliances. Okay, so we follow ASME, that is American Society for Mechanical Engineers code. Then we use TEMA, that is Tubular Exchanges Manufacturer Association codes. Then we use for API, BIS, and other applicable codes. So key consideration in design includes that temperature and pressure, mechanical strength, corrosion allowance, welding requirement, nozzle contraction, support foundation, insulation requirement, and then finally inspection and testings. Okay, so what are the outcomes from this? Again, safe and reliable operation, high efficiency and productivity, long equipment life, low maintenance cost, compliance with standards, better performance, lower cost, and sustainable future. So these are the outcomes of a better design or selection of chemical engineering equipment. Okay, finally, let us discuss the characteristic of a good chemical engineering design. Okay, so we have already discussed all the points, so I'm going to go very quickly on this. Okay, you can even pause and read if you want. A good chemical engineering design should satisfy both engineering and business objectives. It should ensure safe operation, product quality, efficient utilization of raw materials, minimum energy consumption, low maintenance requirements, and environmental compliance. The design should also be simple to operate, easy to maintain, flexible for future expansion, and economically profitable. A successful chemical engineer develops these designs by collecting process data, analyzing operating conditions, selecting suitable equipment, and communicating ideas through engineering design, drawings and flow diagrams. Ultimately, a good design minimizes risk while maximizing productivity, safety, and profitability. Okay. Now, just in case if you think I have gone very fast, you can either pause and read, or you also have an option of where you can slow down the speed of my communication and understand easily. You can go through again and again also. So in this chapter, we introduced the field of chemical engineering, plant economics, and understood importance of role of chemical engineers in modern industries. We learned that chemical engineering design transforms ideas into industrial reality, while plant design ensures safe, economical, and efficient production. We discussed why plant design is necessary, studied the importance of process design, understood the role of equipment selection, and finally explored the characteristics of good engineering design. These concepts provide the foundation for the remaining chapters of this course, where we will study project development, equipment selection, plant layout, and economic evaluation in greater detail. Thank you for your attention. In the next chapter, we will begin with development of project for plant and process design. Thank you.